Hi, Assalamualaikum. My name is Nur Aziza Atira binti Abdul Aziz and my metric number is DE220131. And today I'm going to explain about the calculation for question number 1. As for number 1, it asks you to design an overdam, underdam and critically dammed circuit and find the VT and ILT for it. As for overdam, alpha must be greater than omega given. As for alpha, we are using the formula 1/2RC, which is R is 10 ohm and C is 10 millifarad, and the result will be 5,000 for the alpha, which is we can define it as overdam as it is greater than the omega given. To find VCT, first we find the S1 and S2 for the overdam circuit. So we use the equation VCT equals to A1 exponent power of S1t plus A2 exponent power of S2t. And after we found the S1 and S2, we substitute it into the equation. We found the value of A1 and A2. After that, we can substitute the A1, A2, S1 and S2 into the equation for VCT. As for ILT, the formula is IT plus ISST. So we only have to find the ISST, which has already been given, which is 2 ampere. And then we can substitute it into the formula for ILT equal to IT plus ISST. For critically dammed circuit, we change the value of R, which is 100 ohm, so that the alpha that we have is 500, which is equal with the omega given, that can be defined as critically damped. And then S1 and S2 is equal to alpha, which is negative 500. And the formula for VCT for critically damped is A2 plus A1t exponent the power of alpha t. We need to find only the A1 and A2 for critically damped. After we have found A1 and A2, we can substitute it into the VCT equations for critically damped, which is A1 plus A2 plus A1t exponent power of alpha t. After we have found the VCT, and then we can substitute it into the ILT equation, which is ILT equal to ILT plus ISST. ILT is A1 plus A2t exponent the power of negative alpha t plus IST, which we have ILT is 20 plus 10 kilo t exponent negative 500t plus 2 ampere for the ISST. And lastly, for the underdamped circuit, we change the value of R, which is to 1 kilo ohm, so that we have the alpha is 50, which is alpha is smaller than omega, that can be defined as underdamped. And then we found the omega d for the underdamped, which is the roots of omega squared minus alpha squared. We have 497.5. And then we can put it into the equation for underdamped, which is VCT equal to exponent the power of negative alpha t multiplied by A1 cos WD omega dt plus A2 sine omega dt. And then we can find the A1 and A2 for underdamped. After we have found A1 and A2, we can substitute it into VCT, which is the equation for VCT. And after that, we can find ILT, which the formula for ILT is IT t plus ISST, whereby the ISST is the same value, which is 2 ampere for each second. And that's all from me. Thank you.
Hi, Assalamualaikum. My name is Uswatun Hassan Abdi Zakaria and my metric number is DE220091. Okay, in this presentation, I'm gonna talk about the simulation that we need to do in doing this project. Okay, we are required to construct 3 circuits to simulate 3 cases on transient response, which is underdamped, critically damped, and overdamped cases. Okay, for these 3 circuits, we use the same value of inductor and capacitor, which is the inductor 1 Henry and the capacitor 10 microfarad. In this circuit, we only change the value of resistance. Okay, for the underdamped, we use 1 k ohm resistor, and critically damped, we use 100 resistor, and for overdamped, we use 10 ohm resistor. Okay, let's see the simulation through transient analysis. Okay, the time frame we use 0.06 seconds, and for the output, we're gonna look at the voltage versus time first. Okay, run. Okay, as we can see, we can see that this is the transient response. The red one is the underdamped. The green color is critically damped, and the last one is overdamped response. Okay, we know that underdamped response oscillates without decaying envelope. The damping ratio of the underdamped is always less than 1. The more underdamped the system, the longer it takes for it to reach the steady state. As you can see, as stated here. And then the critically damped response show the response that reach the steady state value fastest than other. In the ideal case, it should not have oscillation to reach steady state. And for the overdamped response, okay, the blue color, okay, the response also doesn't oscillate to reach steady state value, but in this case, it may take longer to reach steady state. And then we gotta look at the current graph. We're setting the output to I. Okay, as you can see, this is the transient response for current through inductor versus time. Okay, as you can see here, same goes to the voltage graph. The critically damped reach the steady state value fastest than others. Okay, for the question D, we need to find the 18% of the VT value. Let's see to the graph. Okay, for underdamped, we can see here that the peak value of final voltage is 251.7 volts, and for the 18% of the peak value is 187.1 volts at the shortest time that can it reach the steady state is at 2.16 milliseconds. And for the critically damped, the 18% of the peak value is 82.13 volts. Okay, time to reach 18% of the peak value of critically damped response is at 2.16 milliseconds. Same goes to the underdamped. And the last one for the overdamped, the 80% of the peak value is 9.779 volts, and it may take 2.16 milliseconds also to reach the steady state. So we can see here that for all the cases, underdam, critically damp, and overdam, for the 18% of the peak values, the time to reach it is 2.16 milliseconds, but the percentage of the improvements of these three cases, underdam, overdam, and critically damp, is different due to the different ratio of damping ratio. Okay, that's all from me. Thank you.
Hello everyone, my name is Aziz Tazri bin Faizli and my matrix number is DE220169. So what I'm going to do now is to do my part of our group presentation, which is regarding question 2 for the calculation and the simulation part. As you can see, question 2 consists of two questions, which is A and B. The A question is, if given Vg equals to 25 sin 200t V, simulate the steady state current and voltage Ig, Ia and V0 compare it with my calculation. As you can see, this is the calculation for question 2, and the value that I get for Ig is here, which is 3.19, and for Ia is right here, which is 0.55. And for the value of V0, as you can see, after doing the circuit reduction here, I get the value for V0, which is 10.89. And then for the B part of the question is to plot the steady state currents and voltage for the Ig, Ia and V0 response. As you can see, I have already done the simulation and already plot the steady state current and voltage graph. So now let's see how I get this answer. So this is the question. This is the circuit for the question 2. As you can see here, the frequency is not given in the question. So what we need to do is, by using the formula of omega equals to 2 pi f, we will then get the correct frequency for the circuit. So what we need to do now is to click here and to pick up transient, and then we need to click run, and this chart will automatically pop up. So what is this three types of wave here? As you can see, they are different in colors, which is we have red, green and blue. So for the red one, it symbolizes the value of Ia, and for the green one, it is the value of Ig, and for the blue one is for the latter, which is V0. So now what we need to do is to click the cursor and show the cursor. So this is the cursor that we will be using. As you can see, it will affect the value in the data below. So now with finding the value of Ia, it is simple. We just right click on the cursor and go to the next Y max. Okay, this one is the Y max that we will be using because there are another two datas that we want to see. And just add data label at cursor. And then for the next one, we do the same. Except this time we use Ctrl+Shift+2 to get the next one to the left of the Y max value. And just click add data label at cursor. And then click on here, or click on the blue first. and then the same thing, and add data label at cursor. So this is the value for IA, IG, and VNode. Now to compare this answer with what we get, just here, as you can see here, IG is 3.19, which is here, and the value for IA is 0.55, which is here, and the value for VNode is 10.89 something, which is roughly close to what we get by doing the simulation. So as you can see, the value is not so much difference. This is maybe because in the simulation, I'm going to close this now. In the frequency part, I did not use the full value for the currency because the full value is longer than 3.18.30. It is 3088 something. So that might be the cause for the slight difference in the value. So that is all for me. And that is the end of our group presentation. Thank you.